Hello. Okay, so we're here and we're here. Now, what we're going to do is we're going to figure out our numbers. Hello, everybody. Hello. Excuse me. We are going to figure out how to read this abacus. Hello, hello. Hey, Cody. Welcome, welcome, welcome. So when we're looking, we have our number. We have our number, 2,678. That's what we're doing. So on the abacus, we're going to do 2,001, 2, 600, 5, 6, 7, 5, 6, 7, 8, and then we have 8. 5, oh, sorry, that's 7. 5, 6, 7, 8. So what we're done. So when we're looking, we have all these reckoning bars. We all have these beads. Notice that there are 4 columns touching the reckoning bar. This is the reckoning bar. These are the 4 columns. All these beads are touching. So it looks like there's only 4 columns, 4 digits, 4 digits that are being counted. So we have 2, 1, 2. Notice 1, 2. The top bead is not counted, and these 2 bottom beads are not counted. So that leaves me with 2,000. Now, how do I know it's 1,000? I know it's 1,000 because every column is a place value. So when we're looking, we have our 4 digits. What is 4 digits? 4 digits to the thousands. So then I have 6, 5, 6. So you notice that the top beat is a value of 5, and then we have 6. So we look at 5, 6. And then after that, we have 5, 6. Notice if we have one more bead, now we have 7. We have 5, 6, 7, and then we add one more bead, right? This bead, then we have 8. 5, 6, 7, 8. Anytime the beads are touching the reckoning bar, it is considered counted, right? So we do 2, 1, 2. We have 6, 5, 6. We do 7. Look, 5, 6, and we add one more, 7. That's what it is. And then we have 8, 5, 6, 7, 8. All right, so we're done with that, and then we're going to go up to 7,002. It's not 7,002 because and just means that there's a decimal, and the decimal would be over here. But this is not and 2. This is just 7,000. So we do 7,000, 5, 6, 7 on the abacus. Notice that this is my thousands. We have 0, 0, 0, and then we have the 2 here. So the 2 is in the ones place. That's what 7,002 looks like. On the abacus, we have 7,000. So 5, 6, 7, 0, 0, and then 2. 1, 2. Welcome, everybody. Welcome. Thank you so much for joining. Hello. What we're doing is we're learning how to read the abacus. We're learning how to read on the abacus. We're learning how to read numbers on the abacus. Welcome to Midnight Math. We are doing math. We're doing math. But we're going to do math with an abacus. That's what we're doing. So my next number is... No, it's not 6, 7. It's a 5. Look, this looks like a 5, doesn't it? It's 5,634. I'm not sure. It's nighttime abacus lesson. It is spooky, Jen. Welcome, welcome, welcome. No, Victor. If you don't know your numbers, then this might not be the room for you. This is not 6, 7. This is 5, 6, 3, and then 4. So if we look at 5,634, that's what that looks like. So all the top beat is a value of 5, and then we have 5, and then 5, 6, and then we have 3. 1, 2, 3, and then 4. 1, 2, 3, 4. So that is what 5,634 looks like. Welcome, everybody. Welcome. Is better than 6, 7. Thank you. I do appreciate those comments better for now. So what we're doing is we're reading the abacus. This is a counting tool, and a counting tool like a math manipulative. That's all it is. We're just learning how to read the numbers. Bro, what did I do? You just come in the room barging saying 6, 7 instead of sitting down and just kind of like, oh, I wonder what they're doing. You know what I mean? How do you read it? That's what I did. 5, 6, 3, 1, 2, 3, 4. 1, 2, 3, 4. That is how you read it. Whew. Hello. Oh, hey. Welcome, Casey. Thank you. All right. So again, if you read the numbers 5,634 All we're doing is we're putting it on the abacus, 5,634. That's all we're doing. So the top bead is a value of 5, and we have 1. Because we have the 1 touching this reckoning bar, we have 5, 5, 6. We have 3, 1, 2, 3. If I add the top bead, that is now 8. Because if we add the 5, that's the value of 5. If we add the 5, then we have 8. 5 plus 3 is 8. And then we have 4. 1, 2, 3, 4. Because we have 4 beads touching the reckoning bar, it is considered counted. If I added the 5, then we have 9. So if we take away the 5, then we have 4. 1, 2, 3, 4. I don't even know. Stover the Rad? What's the point of you being in my live? Is there a point for you? Why are you here if you're asking? So that is what we're doing, and I'm going to color it in on the abacus. So we have 5, we have 5, 6, we have 1, 2, 3, we have 4. 1, 2, 3, 4. My brother's really smart now. Thank you, Mini Ninja. That's funny. You're going to be just as smart. You know what? Is your brother older or younger? Because if your brother's older and you start abacus, then you'll be faster than your brother because you're younger and you can get abacus faster. Because if you start young, you'll know. I started late, so I'm not as good as my kids. My kids know it. He's younger. Oh, I'm sorry. Because he's younger, he will be faster. So we have 9. I'm sorry. We have to do 9,829. So how did I get 9,829? Well, we're going to look at the beads. When the beads are touching the reckoning bar, we have 5, 6, 7, 8, 9. We have 8. 5, 6, 7, 8. We have 2, 1, 2, and then we have 9 again. 5, 6, 7, 8, 9. So when I count it on the abacus, I'm going to color it in. We do 5, 6, 7, 8, 9. We have 1, 2, 3, 5, 6, 7, 8. We have 2, 1, 2. And then we have 9. 5, 6, 7, 8, 9. Yeah, I'm sorry. My kids are faster. Can you go over the combo addition, this fraction, 72 plus 90 minus 38? Yes. Okay, Amy. Can you do an easy one like 1, 2, 3, 4? Oh, yeah. Here we go. So here we go. 1, 2, 3, 4. Thank you, Amy, for the comment. Does that make sense? So when we're looking, we have 5. That's it. So we have 5, and then remember this is 1, and then I add the 5, it is now 6. If I have 2, 1, 2, I add the 5, then I have 7. If I have 3, 1, 2, 3, then I have, add the 5, we have 8. And then we have 1, 2, 3, 4, add the 5, and then we have 9. Yeah, no, Amy, thank you so much for the hello, Edric, thank you. Hello, Chaotic. Welcome, welcome, welcome. So, yeah, thank you, Amy, for letting me know. And, yeah, it makes... Okay, good. So now, if you're looking, every column is a place value. So we have 9. 10 looks like this. 10 is a 1 and a 0. And then we have 11, 12, 13, 14. After 14, we have 15, 16, 17, 18, 19. And then we have 20. 20 is a 2 and a 0. There's 2 10s in the 0. 2 10s and a 0. So that makes it 20. And then we do 30, 40, 50, 60, 70, 80, 90, and then 100. So we just did a 3-digit number. 001. 100, 100. How long do you go live in a day? It depends. Sometimes I go 5-6 hours in a day. It all depends. Okay. So, are all the rows counted the same? Yes. So if I did this would be 9. And then this would be 9. So it would be 9, 9, 9, 9, 9, 9. Yes. This is definitely a throwback. Oh, good. Yeah, that's dedication. Thank you. I do appreciate that. I do have stuff also available. But yes, it's also one of those things that not everybody knows what an abacus is. So I would like to help Spread the good word of the abacus into the matrix. I'm here. Welcome, everybody. Welcome. I am here to introduce abacus to the matrix.
Welcome to the real world.
Thank you. I follow you. I love your teaching. Thank you, Jerry. Oh, that's so cool. Shaggy and Scooby Doo. Fantastic. Oh, good. You're still here, Rad. Steve-O. I'm seeing this just a different way of showing. Yes, exactly. That's what it is. What's the point? Usually it's for the kids. Usually it's for the young kids. Usually it's for kids starting really young, maybe 5. I'm trying to get them younger at 3, 4, and 5. Sometimes it's for accommodation for those people that are having problems seeing, and they can use an abacus to help them do adding, subtracting, multiplying, and dividing. Sometimes it's used as an enrichment program for those people that are already done with the mainstream math and they want some challenging stuff and they want to go into abacus. But I am here to show the average people what an abacus is. Thank you, Edric. Thank you, Edric, for the gift. So what we're doing is we're learning how to read the abacus. We can actually do add, subtract, multiply, and divide. But yes, thank you, everybody. When you are here, please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
People like me. Chaotic. That's funny. Yes. So, resolve. That's easy. 100, 20, 0, add 50, add 5, add 0. So my answer is 170. All right. What's the benefit compared to a calculator? You can, what's the, brain gymnastics. That's what it is. If you do Sudoku, if you do jigsaw puzzles, if you do word searches, abacus follows the same path. If you don't like any of that stuff, then maybe this is not the class for you. Just saying. I'm not here to judge. I'm just letting you know. If you like puzzles, then you're going to enjoy the abacus. But if you don't like puzzles, then you're SOL. So, that's a plus. All right. So, treasure, we will keep that. We will pin that. And we're going to keep going. So, thank you, Chaotic. Yeah. Okay, show division multiplication. No. Don't be pushy. You don't even know how to do adding and subtracting. That's too easy. So it's faster. Okay, sorry. Okay, so again, when we're looking at it, we have 4,319. I'm not a Razul Bashar. That's very demanding of you. Okay, isn't there usually, oh no, that's a Chinese abacus. Learn to walk before, yeah, right? No, Wise Tiger 3434. That is a Chinese abacus. This is a Japanese abacus. This is a Chinese abacus. The Chinese abacus has 2 beads on the top and 5 beads on the bottom. So when we're looking, we do 1, 2, 3, 4, 5, and then we have 6. I'm sorry, this is 5. Because this is 5, we're going to trade this in to make this a 5. So we have 5, 6, 7, 8, 9, 10. Because this is 5, we're going to trade it in, and then we have 10. So we have to we got to trade it in, and then this is 10. So when we're looking, we have 11, 12, 13, 14, 15. But it's similar to abacus. We have 1, 2, 3, 4, and then 5. 5, 6, 7, 8, 9, and then 10. Does that make sense, Wise Tiger? Thank you, Zoltan. Zoltan the Great. Thank you so much. I appreciate that. You're right. You did say please. I apologize. But first, let's start going into the concepts of adding. Yeah? Let's put a pin in that. Because there's a lot of people here that don't know how to read the abacus. So, next their number. Okay. What are we doing? 4,310. That's what we're doing. If you notice, we have on the abacus, we have 4,000, 1, 2, 3, 4. We have 3, 1, 2, 3, and then we have 1. Yep, I'm one of them. Hello, Smooth Operator. Oh, thank you so much. I'm here for a little bit. Thank you for joining. Thank you for stopping by. I do appreciate that. There we go. So we have it again. We're going to color it in. We have 4. I'm sorry, 1, 2, 3, 4. So this is my thousands, just like how we write on the abacus, just like how we write in the number, right? This is 4, 1, 2, 3, 4. We have 3, 1, 2, 3. We have 1, and then we have 0. We have 3, 1, 2, 3, and then 1. And start at the square 1. This is the ones, this is the tens, this is the hundreds, and this is the thousands. Usually I go from left to right because that's how we talk. We talk 4,310. We don't really say 10, 300, 4,000. So when we're looking, I usually go from left to right. So we have 2,000, 2,495. Why am I here? The reason why I'm here is because I have this label. This label, haha, Amy, I just read your mind. So there's a label right here. This is my ones label. This ones label actually tells me where the ones is. And so if you notice, there's a second label here. This tells me the thousands. And so when we're looking, we have our ones, tens, thousands, hundreds, thousands. I'm actually on an app online. It's easier to visualize using whole numbers. Okay, yeah, right? Okay, so we're going to do 2,495. That's it. That's what we're doing. Yeah. Let me finish this, Treasure, and then we will do your question. We have 1,995. 1,995. Thank you so much for letting me know. Now, Amy. So we have 1,000. We have 1. This is 900. 900, 5, 6, 7, 8, 9, and then 9 again, 5, 6, 7, 8, 9, and 5. Yeah, right, Amy? Because when we're looking, it's more confusing for me when you are using the decimal points. This is not a decimal point. This is a label. Is that what you're talking about? Good evening, miracles, Amy. Amy is so funny. You're so funny. Yeah, now it's easy, right? Because if you look, this would be 9, 9, 9, 9, 9. Every column can be 9. It doesn't matter. So then every column can be 8. Every column can be 7. Every column can be 6. Every column can be 5. Then we have every column can be 1. And then every column can be 2. Every column can be 3. Oops. And then every column can be 4. So we have 2,760. That's what we're doing. 2,760. So on the abacus, we're going to color it in 2,000, 1, 2. We have 7, 5, 6, 7. We have 6, 5, 6, and then we have 0. Decimals? Easy. Decimals just happens to be on the other side of the ones place. So the decimal sits between the ones and the tenths. That's all it does. It's just another place value. So when we're looking, it just sits right here. That's the decimal. So then after that would be my tenths and my hundredths. So when we're looking, decimals are very easy. It's just another label. That's all it is. So my next question is 8,478. Thank you, miracles. Thank you, miracles, for the suggestion. So we have 8,000, 5, 6, 7, 8. 5, 6, 7, 8. We have 4. 1, 2, 3, 4. We have 7, 5, 6, 7, and then 8. 5, 6, 7, 8. That's it. So when we're looking, we have 8,000. 8,000 is the fourth column, right? The fourth digit. We have 4, 1, 2, 3, 400. This is the hundreds because why? This is the third column. And then this is 70, 5, 6, 7. So we have the tens column, which is the second column. And then we have 8, 5, 6, 7, 8. We have 5, 6, 7, 8. There we go. So what's next? We have 9,010. 9,010. That's what that looks like. So when we look, we have 9, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, and then 10. That's what 10 looks like because it's a 1 and a 0. What app should I do if I remember? Anyone that says Abacus, really. There's not really much you can do with a free app, but it is there. I don't have any recommendations and I don't have an app yet. I don't have an app yet. So we have 2,917. I know a few people have done that. Hey, me, welcome back. I don't know if it's the same me. There was a lot of me's yesterday. So we have 2,000. We have 1, 2. We have 9, 5, 6, 7, 8, 9. We have 1 and then 7. 5, 6, 7. Yeah, it's me again. All right. Our final number is 1,426. That's what we're doing. So we're going to do it again. We'll do 1,000. Color that in. That's the 1. Here's a 4. 1, 2, 3, 4. We have 2. 1, 2. And then we have 6. 5, 6. Thank you for putting... Oh, yeah. Okay, have a good night, Amy. Thank you so much for joining, and I hope to see you in my next live. I was only in Thai live for 5 minutes. I learned something new. Thank you, Jay. Thank you, Jay Visual. All right, guess what? It is now your turn. I'm done. I'm so done. I don't want it. Okay, no. Let's do it. We're going to do 2 digits, right? 2 digits is just exactly what it is. It is 2 digits. I did 4 digits just to like get you guys going. But now we're going to do 2 digits. What number do we think that... Simple sort... Oh, wait. Hold on. What I got to do is... Before I forget. All right. 97, right? Treasure? Then what? Plus 7 plus 2. Do you remember how to add the 7? Plus the 7 is what? Plus the 10 minus 3. Plus the 10 minus the 3. And then can I add the 2? Yeah, add the 2. What's next? Take away 3. Take away 8. Take away 3. Do you remember how to take away the 3? Minus the 3. Can't take away the 3. I have to minus the 5 plus the 2. Minus the 5 plus the 2. And then minus 8. So my final answer is 131. 131. Did that make sense, Treasure? Or did I go too fast? I never learned multiplication on the abacus. Oh, really? That's interesting. That's very interesting. What kind of abacus? Slower? Okay. Let's do that again. Too fast. Okay, sorry. Well, Treasure knows formulas, right? Do you know formulas? Do you remember the formulas? So we have 97. I stopped at addition and subtraction. What kind of abacus did you use? I used this one. Oh, interesting. Oh, and you stopped at adding and subtracting. That's interesting. That's very interesting. Okay, we got 97. We're going to add what? We're going to add 7 and we're going to add the 2. Well, let's add the 2 because it's easy. Add the 2. Now we add the 7. Do you know your formula to add the 7? What's the formula to add the 7? You went to, oh, hey, abacus class in Taiwan. Was it part, Mr. Lee, was it part of the class or was it an enrichment program? Plus 3, minus the 3, plus the 1 to the left. Yes, thank you. You're right. Plus the 10, minus the 3. Thank you, smooth operator. Right? That is how we plus the 7. Yes, so these are formulas that we have to memorize. So what's the next one? I'm going to take away 8 because it's the easiest. Take away 8. I need to minus the 3. Minus the 3 begins with the 10. No, you could. You could. It doesn't matter. You need to just track it. So we have minus the 3. Minus the 3, I cannot take away, right? There's only one. So the next one I have to do is minus the 5. Minus the 5 is, no, nobody knew how to abacus. It was another class my mom got me. Oh, interesting. I didn't like it, so I quit. Oh, yeah. But you know what, Mr. Lee? I'm just telling you right now. I don't know if you were here for this, but I'm actually making abacus fun. My kids hate it, but I'm making abacus fun. That's what I'm doing. And so I have these mazes, and they're fantastic. And then, let me show you. I'm actually quite excited now. I have all of these abacus books. So here, we're adding of the 5. And then I have more activities. So these are all the activities that they get to do. All about the abacus. All right. Yes. Minus the 5 plus the 2. Wow, you made them? Yes, I'm on book 15 right now. What age do I start? Well, if I can start the kids young, I would start them at 3 or 4, and you can utilize this one right here. This is the preschool abacus, and they're all abacus focused, and they're all abacus mazes, but it's all about just learning how to read the abacus and understanding how the tracing is, and just trying to make it more fun for them. Yeah, yeah. Would you say you're an abacus addict? I think so. I think so. I really do believe that abacus is the greatest thing. And I believe that abacus is very good. So we have 9, 7. We have 7 plus 2. We have take away 3. Take away 3 is minus the 5 plus the 2. And then minus 8. So yes, the answer is... Ah, you make it fun. Thank you. Thank you, me. Okay. It is fun. I was a math major. It is like a puzzle. Yes, it is. Oh, that's great. An abacus on treasure? Is it a 7-bead abacus or is it a 13-column abacus? I like abacus too. Someone donated. Hey, I was floored. Oh, that's really cool. What kind? You probably love Rubik's Cube. Oh yeah, that's the other one. Rubik's Cube. Yep. I like the abacus more visual and the formulas are patterns. Yes, exactly. 13. Oh, okay, good. 13 is good. What is an abacus? An abacus is a counting tool. Thank you, Yvette. Yes, me. It is 131. Okay. Jay, I hope that answered your question. I didn't. Oh, yeah. Yeah, my boys didn't like it, but I made sure that they know how to multiply and divide on the abacus. Are these your own brand of abacus? Yes. These are the abacus I am selling on TikTok. Why do you not? Oh, that's a good question. Because I have a label right here. This is my ones label. If you notice this, and then after anything after the ones, right? After anything of the ones, it'll be my decimals, my tenths and my hundredths. Thank you. Thank you, Yvette. In my 30s, how do I learn the abacus? That's what we're doing. That's all we're doing. Oh, thank you. Not a problem. Sorry, I just had a funny thought. If your boys are bad, you hit them with the abacus? No, I didn't do that. If they didn't get the right answer, I just tell them to do it again. Because they need to understand why they got it wrong. And that's really old school. Yeah, no. All right. Yeah. Yeah, I know. That's like old school, but no. I wasn't a tiger mom either. I just let them do, and if they can do it, then it's great. If they couldn't do it, but they had to finish it. They just needed to finish it. They should teach abacus in public school. That's what I'm trying to do. My goal is to get them into public school. My goal is to make it entertaining enough and to compare to mainstream math because it is pretty fantastic. All right. So that was just an example of that. So now we're back to here. Okay. Here we go. What is our number? We have our tens and we have our ones. If I have this on my abacus, what number do you think that is? What number do you think that is? 61. Thank you, Squeedy. Thank you, smooth operator. Yes, 61. What is our next number? We have our hundreds. No, we have our tens and we have our ones. Thank you, Squiddy. Thank you, smooth operator. Johnny, sit back a little bit and you're going to get it. Because I usually explain how to read the numbers. So we have 1, 2, 3. This is in the tens. This is 9. 5, 6, 7, 8, 9. That's it. Thank you, Monty. 30. That's funny. I know how to read that. I don't usually know how to read Chinese. I'm very, I don't read Chinese. Okay. What's our number? We have our tens and we have our ones. What number? I'll be watching your... Oh, good. Are you Korean? No, I'm not Korean. I'm Chinese. What point? What is the point of this? That's very rude. Oh, hey, Naya. Oh, just curious. What's the point? It's to math fluency, math flexibility, stronger foundation in arithmetic. So you can add, subtract, multiply, and divide, but the first thing you need to do is you need to read the abacus. No, I'm trying. No, it's. Oh, I see. Right. Abacus is the way. Yes. Yes. Where is it?
This is the way.
This is the way. This is the way.
Thank you, Mr. Lee. Yes, it strengthens your memory. It actually provides analytical, critical thinking as well, which is crazy. It adds critical thinking, and we will get into it. And when we start doing adding and subtracting, you'll start seeing the nuances of critical thinking, because when you're restricted on the abacus, like you can't do certain things, the abacus actually starts to get you into doing critical thinking. This is my. Oh, good. Oh, good, Naya. Oh, good. Yes. So thank you everybody for joining. Thank you everybody for joining. For those of you that are interested, please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Okay. Yes, 64, 5, 6, and then 4. 1, 2, 3, 4. Welcome. Thank you, everybody. Thank you, 64. And I take it down to here. So what's our next number? Thank you for... I wasn't trying to... Okay. Yeah. You know, because we only have comments. And so some of the comments, a lot of people just say 6, 7. And I'm like, okay, that's not enough for me. Yeah. Thank you. 3, right? Easy. Simple to use. Simple to use, easy to understand. So that's the 3. And then we have this number over here. We have our 10s. And we have our 1s. We have our 10s and we have our 1s. We know this. This is easy. Easy, easy, easy. Yes, 99, right, Squeety? Yeah. Hi. No, it's not 8. 8 looks like that. That's what 8 looks like. So even up here, even up here, that's not 8. Because if you look, we don't have the top bead is touching. This is only a 3. That's what it is. 1, 2, 3. When we have the top bead is touching, then we have 8. Yeah. But that's good choice. Good guess. Yeah. How do you explain how to get 99? Well, how do I get 99? 5, 6, 7, 8, 9. This is my 1s. This is my 10s. That's how I get 99. So when I'm looking, I have 5, 6, 7, 8, 9. That's it. If I had this would be 44. Right? 1, 2, 3, 4. 1, 2, 3, 4. But now I had the 5. The top bead was always 5. Anytime the beads are touching the reckoning bar, it is considered counted. So we have 5 beads, 5, 6, 7, 8, 9, counted on the reckoning bar. We have 5, 6, 7, 8, 9, again, touching the reckoning bar, it is now counted. Yes. Thank you, smooth operator. Yes. Yes. Thank you, Squeety. Yes. So the top bead is a value of 5. Does it matter? It kind of does. Columns do matter. Because you're looking at here, this is my label. I start here as my 1s place. So when I'm looking, right, at my 1s here, and then I have my 10ths and then the hundredths. So my decimal sits right here. That's why I have this. And then you'll notice I have another label here. This tells me the thousands. I just imagine ancient Egyptians using abacus with a lightning speed. Can you make it on any lines as long as they're together? Yeah, kind of. Kind of, but I would actually still keep the label of my 1s here. For me, because I've been doing it for about 20 years, I would get confused if I had to start from here, and then I'd be like, I walk away, I come back, I wouldn't remember where I started my number. So I would kind of do it this way over here. Okay. If the columns were 10s and 1s, what's to the right? To the right is the 10ths and the hundredths. I literally don't understand. Hold on, Erica. No worry. Okay, yeah. No. Erica, 1, 2, 3, 4. Do you understand that? Hey, Riku, welcome. Trust the process. You don't understand that this is 1? You don't understand that when the bead is touching this reckoning bar, this is considered 1? Do you understand that? Can you explain the tenths and the tenths? When you add, I'm sorry. Okay, wait. Wait, does it matter the order of your value, or do... No, for Squeety, you don't need to go... As long as you track your columns, you can go left to right or right to left. It doesn't matter. Okay, Callie. 10 is this. There's a decimal. 0, 0. Tenths is a 0, 1. That's what that is. That's the tens. This is the tens. This is the tenths. Yeah. It's just like regular math. It's just like regular math. We have our tens, ones, tens, and then we have our tenths. This one is our hundredths. This is always this is always the ones. This is the ones. Yeah. Tenths is the decimals. Decimal after the decimal. Yeah. Erica, are you all right? How are we doing? So do you understand when I'm adding the 1, this is 1, and then I have 2, 2. Does that make sense? This is 2. This is 3. 1, 2, 3. This is 4. 1, 2, 3, 4. Not slow, unfamiliar. Unfamiliar, because this is a brand new thing. If you really think about it, it's a brand new thing. It's unfamiliar. So after 4, the top beat is 5, no matter what. So this is 5, 5, 5, 5, 5, 5, 5, 5. These are all 5s. So when I'm writing it, I have, if I did this, 55,550, I'm sorry, 55,555.55. That's what that looks like. Oh, give it at least 3 days. Naya. Because Naya was the same way. She's like, I don't understand. I'm like, hold on. I'm not going to say my mind. Oh, okay, cool. Thank you, Anthony, for the comment. Can any column be the tenths? I usually use this as my ones. So then after my ones will be my tenths. You could choose this to be your ones and then this will be your tenths. Your tenths will always be to the left of the label. I think because you're using the placement value, it's not the book example. It's confusing. Not on the book. I don't know what that means, Treasure. Where does the decimal come in? Only if you want to go after, only if you want to put something in the back. Usually we do that, right? Usually if we did 1, we don't do 1, 0, 0 like money. This is our $1. If I want to do $1.25, I understand. Mr. Lee. Right. Let's see. Right? The book examples don't show decimals. No, they don't. But the questions are, why do we have decimals? What's a tenth? That's why. So when we're looking at it, I always understood the way. I think I got it. Yeah. So if we want to do, when we look at it, we do 4. When we do 4, we do that. That's what 4 looks like. That's it. This becomes 0 and 0. We don't worry about the decimals because it's after the decimals. The dot on the board is not a decimal. You're right. Thank you, Montoya. Yes. Montoya. Yes. The dot here is not a decimal. The dot here is a label. This label, I mean visually for newbie. Oh, this dot right here is telling me this is the ones place. That's it. Thank you, Montoya. Montoyas. This is not a decimal. This is the ones place. This tells me where the ones is located. You're right. Off 2. Okay. See you later, Naya. Right? So when we're looking here, we did 99. We don't need to worry about the whole numbers. We have our tens. We have our tens and we have our ones. Sorry, subtraction. Thank you, Aiden. Yes, 91. 5, 6, 7, 8, 9, and then the 1. 5, 6, 7, 8, 1 in the tens, and then this is 1. So we have 91. Thank you, Aiden. 91 takes me to here. What number do we think this is? Off topic, what about the 3-digit multiplying by a 2-digit number? 75. Yes, thank you. 75. What about it, Naya? Did you want to do one of those? Thank you. 75. 75 takes me to here, and I'm over here. But we have to know our formulas before we go into doing multiplication. We have our tens, and then we have our ones. 54. Thank you. You're right. Thank you, Aiden. Naya. Oh, then you get a 5-digit number. Oh, yeah, that's right. Thank you. So it is 54, and then we have our next number. What is our next number? We have our tens, and we have our ones. Oh, excuse me. 25. Thank you. 25. Thank you. Yes, thank you. So 25 looks like that. Thank you, Smooth Operator. Thank you, Callie. Thank you, Naya Montoyas. Yes, welcome. Are my math teacher? I am an Abacus teacher. I've been teaching Abacus for 20 years. I've been teaching Abacus for 20 years in Los Angeles, California. We have a learning center out in Monterey Park. So we have our ones. We have our ones and our tens. What number do we think? Oh, yes, thank you. 58. Thank you. Thank you, thank you. What is an abacus? Oh, awesome. Oh, yeah. 20 years is a long time. But I still enjoy it, and I still enjoy inspiring people to learn how to use the abacus. So an abacus is a counting tool. A counting tool is usually just for math. That's all it is. It's just for math. So we have our next number. We have our tens, and we have our ones. Thank you, Naya. Yes, it is a math tool. I love LA, but the 6 hour, it's a 6-hour drive. Abacus is a great way for kids to learn math. It is presumed. Yes, it is, Aiden. Thank you. It is 42. Thank you, Naya. Thank you, Montoya. Is it used for children? Yes, honey, it is useful for children. The reason why is because they can visually see the numbers, so they don't have to understand what the symbols are, right? So what, the thing is, if you really think about it, the numbers themselves, like 8, is actually a symbol. But on the abacus, we can see that this is 8. We know it is comprised of 5 plus 3 is 8. And so when we're looking, all of these things that are like numbers, this is a symbol. And so what the abacus is doing is it's telling you visually what it is. So we see that this is 1 bead. This is 2 beads, 3 beads, 4 beads, and then this is 5. This is a representation of 5. And then we can add it to 6, 5, 6. 5 plus 1 is 6, 7. 5 plus 2 is 7. Math is always my worst subject. I always failed this. So this is confusing, but I'm slowly getting it. Yeah, it takes a little bit of time because it's something different. It takes a little bit of time because this is unfamiliar. Right? Thank you, everybody, for joining. Please keep your mind open.
Now, open your mind to me, please. Open your mind.
Usually for young kids, it doesn't matter what row. But as they get older, you're going to start labeling this one right here. So you'll see that there's a ones indicator. The ones indicator will tell me where the ones place is. So we have our ones, our tens, hundreds, thousands, and 10,000s. Thank you so much. You're a great teacher. Oh, thank you, Erica. I apologize for the rudeness. It was just one of those things when people start flooding like questions. I'm not sure if there's trolls or not. So for those of you that are interested, this is my preschool book. This preschool book is meant for children that are 3, 4, and 5, and they're just learning how to do their numbers. And when you look, like the number 3 is actually a symbol, right? Hands is just a bunch of, exactly. These are just a bunch of symbols. But when I do it on the abacus, like this is 4, 4 dinosaurs. 1, 2, 3, 4. Same thing on the abacus, right? So it's a 1-to-1 representation here. However, when we get to the 5, we have to start using the top bead. The top bead is a value of 5. And then that's the lesson 2. So lesson 2, we talked about 6, 7, 8, and 9. What does that mean? We just do 5, right? 6, 7, 8, and then, 8, and then 9. So every column is 9, can be 9, 9, 9, 9, 9, 9, 9, 9. And so when we're looking, we're trying to understand how to read the abacus, and that's what this is. So then in this book, I talk about how to count forward, and then afterwards we talk about counting backwards, and then we start understanding the relationship of the numbers. So if I give you a number, the before and after, what's the number in between? Don't apply, it's totally okay. There's a lot of rude people here. I catch you. Oh, thank you, Erica. Thank you for your patience. Okay. So if I give you the number 7, you have to tell me what number is before and what number is after. And then after that, we do comparison. Yeah. And that's it. So now we get to the point where we need to add. What are we going to do? How do you do 10? Ooh, that's a good one. So 10, that's it. That's it. Why? Because we have our ones, tens, hundreds, thousands, 10,000s. 10 is a 1 and a 0. This is a decimal system. This is a base 10. This is not a base 5. This is a base 10. We go all the way up to 9 to 10 digits. And you move to the next column. Yes, we go to the next column. And so when we're looking, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can count 20, 30, 40, 50, 60, 70, 80, 90, and then 100. So in Abacus World, what we're going to do is we need to understand the second number. In Abacus World, we need to understand the second number. The second number is what we're going to do. We're not going to memorize. No need to pay a teacher. We have Miss Lena. Thank you, Naya. What we need to do is not focus on the result. We need to focus on the process. Marry the process. Divorce the result. Well, I'll be back later tomorrow. Okay. Have a good night, Erica. Have a good night. Haha, Pearl, thank you so much. Yeah. So, again, if I have 7 on the abacus, 5, 6, 7, I want to add 1. Can we do it? Yes, we can. We can add 1. That's all we're doing. So my final answer is 8. 5, 6, 7, 8. So notice that we have these extra beads that we can add. And that's what we do with the 2. When we do with the 2, the question is 6 on the abacus. Can we add the 2? Yes, we can.
Come on, do it. Do it.
Yes. So we add the 2. That's it. So my final answer is 8. And then we do it again. Here we go. So we have 5 plus 3, right? You could do mainstream, which is the dots. You could do the tallies, which is not a problem. Or, thank you, Amanda. Or, we could do 5 plus 3 on the abacus. Right? Yeah, Amanda, right? Everybody needs to eat. And you're absolutely right. I need to eat. And I don't do this for free. I have product. And what I want to do is I want to explain how to use the product. Let me know if you guys want a review. But that's what we're doing. We're doing a review. But Amanda, Naya is young. She probably believes that teachers live in the school. I did when I was a kid. Base 10, is valuable in computer science or back in my day. Base 10 is still very important in adding, subtracting, multiplication, and division. Our whole system is base 10. So what we could do is we can actually scale it. So we have 5, 50, 5, 0, and then 30. 1, 2, 3. 5 plus 3 is, 50 plus 30 is 80. I love your knowledge and language. Thank you, honey. Yeah, I understand, Amanda. Yeah, I understand. And you know what, Naya, just so you know, we don't do calculus. You want to go higher. After you figure this part out, you're going to go into more complex math. But I'm just here to teach you how to do arithmetic. That's all. Okay, so here is what it is. This is what 50, and this is 30. That's a whole lot of counting. That's a lot of counting. But what I'm going to do here is I can actually scale it. I can do 500, 500 plus 300. 1, 2, 3, and it gives me 800. Do you do matrices in the abacus? I don't know what that means. I don't know the new math stuff. I barely understand what's going on with new math. Is that what you're talking? Like new math is matrices? I just found out about the Japanese lines for doing multiplication, but that's still a 1-to-1, and you still need to memorize your multiplication fact, like the matrix. No. Matrices. No, I don't know. I don't know what that means. That is above my pay grade. I don't know if that's a Common Core thing. So I want to add the 4. I have 5, and when I add the 4, I just add the 4. We go to the horizontal bar, or we subtract from the horizontal bar. Yeah, I don't know what that... Well, I don't know, like, the matrix and stuff. So when we add, we know how to subtract. We have 2, 1, 2. Thank you, Moon, for the rose. Thank you, Moon, for the rose. We want to subtract. We want to take it away from the horizontal bar. We add to the horizontal bar. We go up. We want to take away. We go down. But it's different, right? If I want to take away the 2, I'm taking away 2 beads. So if I have 3 on the abacus, 1, 2, 3, and I want to take away 2, I just take away these 2 beads. It doesn't matter which 2 beads I take away. I got to take away 2 beads. So if I had 4, I take away these 2 beads. And then if I had 3, I wanted to take away these 2 beads. If I have 2, I want to take away these 2 beads. No, it's a math concept doing the matrix. I'm not sure what it is though. I'd have to look it up. But it sounded like it was more complicated than it really needed to be. Somebody was I think I saw somebody doing a matrix. What was it? It was something like the most important class you'll never forget this. It must be new. Yeah, I think it's a new thing. Was a matrix like 3, 2, 3, and then 5, and then 7, and then this is 10, this is 15, this is 14, this is 21, or it's like whatever. 2, 3, 5, 7. So this is 7, this is 8, I don't even know. This is 9, and then this is 10. Something like that. Yeah, you got... Oh, yeah. I don't... This is what I call new math. The matrix is a set of numbers with brackets. Yeah. Yeah. Yeah, I've seen it, and I was like, it's okay. It doesn't pertain to Abacus, though. Because if I did it, we needed to know formulas. So 23, like 2357. We have 23 on the abacus, 1, 2, 1, 2, 3. And then add the 5, add the 7. Add the 7 is what? Plus the 7 is equal to plus the 10 minus the 3. Plus the 10 minus the 3. So my final answer is 80. Representation. Oh, wait, what? Matrix is a... Okay, yeah. Represents the system of equations. Yeah. Yeah. Yeah, I think at this age, like when they introduced the matrices to the kids, I think it's a little bit overkill. Yes, young. It is a toy. No, it's not. It's a counting tool. It's a table with numbers, really. Yeah, you're right. It's just a table with numbers. You mean you do individual calculations with the formula? I don't know. Yeah, I don't know. Anyways. So, we're back to here. When I have to add the 5, all I need to do is add the 5. We go to the horizontal bar. When I subtract, I go away from the horizontal bar. So I have 3 on the abacus. I want to add the 5. And then we do it again with the 6. Here we go. We have 1 on the abacus. We have 6. 5, 6. And we bring it together. We take away the 6. Or we add the 6. You'll notice it's just the opposite. We're doing the inverse. And that's what it is. If you know how to add, you will know how to subtract. Someone explained this is just starting to play on my phone. And it was locked. Back to good. Yeah, so we're back to here, right? So we have 7. So if I put 1 on my abacus and I have 7, right? What did I do? I added 7 on the abacus, so my final answer is 8. What we do is we don't focus on the result. We focus on the process. And so when we have 9, 9 is just everything together or everything take it away. And that's it. So then you must be wondering, smooth operator. You guys, Okay, so you might be wondering, well, what happens when there's not enough beads? This is where the formulas come in. The formulas is what is called number sentences. It's called fact family. That's what it is. It's fact family. And so this one we're doing is specific, is the 5. I think it's the 5 fact family because you're trying to make a 5, which is very different than memorizing everything else. Because you don't need to memorize your nines. The reason why is because the reason why you don't need to memorize your nines is because on the abacus, it's very naturally there. So if I have 1 on the abacus, I want to add 8, right? If you look at that, 5, 6, 7, 8, bring it together. That's my 9. It's easy. But we don't focus on the result. But if you needed to, you could. So if I have 2 on the abacus, I want to add 7, 5, 6, 7, I bring it together. Right. But that's very different than this. That's very different than this. Because this is figuring out what to do with this top bead. So the question is, we're not going to memorize our doubles. For those of you that don't remember what doubles are, doubles is when you have to memorize what 4 plus 4 is. You can either count up, which is fine, or you can memorize your doubles, which is fine too. But in Abacus world, we don't memorize the doubles. What we do is we understand the concept. So the concept is 4 plus another 4. So what are we doing? We want to add the 4. We're understanding that there's this concept. We want to be able to utilize this 5. Because what we're doing is if we want to add the 4, that is not adding 4. That's just saying that it's 44. Right? What we want to do is we want to add 4 to the ones place. To add 4 to the ones place, we got to figure out how to add the 4 here. On the abacus, I have 4. 1, 2, 3, 4. 1, 2, 3, 4. And then what happens is I want to add this 4. Because I add this 4, I don't have enough beads, right? I only have these. But I can give you my 5 cents. If I give you 5 cents, I give you too much. I need to take away 1. So my final answer is 8. 5, 6, 7, 8. We have 5 on the abacus. Take away 1. And so my final answer is 5, 6, 7, 8. Whoa. Yeah, I'm distinctly failing learning the abs in kindergarten. They taught you abacus in kindergarten? That's actually fantastic. Thank you for the follow, Soja. Respectfully, numbers are easier. Numbers are easier, but numbers is a symbol. Just like the alphabets. A, B, C, D are symbols. So if you consider the alphabet and the numbers are symbols, you can't tell me what 4 is. You have to put it into something. So what I'm trying to do is I'm trying to show you the physicalness of a 4. The concept is what I'm trying to do is I'm trying to show you that we can practice again. It is easy to memorize, and that is how we become math illiterate. That's what happens. When you start memorizing, you become math illiterate. But if you understand concepts, why am I adding this 5? Because I now know to be able to balance the equation. So if I have the 5, because I have this, if I have 3 on the abacus, 1, 2, 3, I have 3, 1, 2, 3. I'm going to add the 5 because that's all I have left. But that's too much. I need to balance this equation. I need to take away the 1. So my final answer is 7, 5, 6, 7. You know what? It's just like a bag of avocados. There's 5 avocados in a bag, but I only need 4. What do you do with the 5th one? You throw it away. You know what I mean? What do you do? What do you do if you have a bag of items? You have 5 items in one bag. What do you do with this one here? What do you do with it? That's the difference, right? The difference is if I have 2 on the abacus, 1, 2, and I have my bag of avocados, and they only come in a bag of 5. 1, 2, 3, 4, 5. I only need 4. If I only need 4, what do I do with my last avocado? I gotta throw it away. If I throw it away, do I take it from the bag? No. Take it from this loose one here. And then my final answer is 6. 5, 6. I like the package. Sometimes change doesn't help. What do you do about the toast? Yeah. Right? We could do it again with the 1 and the 4. With the 1 and the 4, right? We have 1 and the 4. We want to add 4. Can't add the 4. I have this package. I have a bag of, I don't know, apples. There's 5 apples here, but I only want 4 because I'm too full. I cannot eat this last apple. What do? I got to take it away. I got to give it to my kids. So I'm left with 5. Add the 5, take away the 1. That's what I would do. I'd eat 4 apples and I give the extra 1 to my kid. Right? And so we could do it again. Why? Because there's this concept. We know. See, that's the other thing is then, honey, why do we teach the kids a fact family? Why do we teach them that they have to memorize this if we don't utilize it? What would be the point? There is no point. Because there's nothing used in mainstream math to figure out how to do this. It is very different. The concept is different. No, not going to lie. The concept is different. It is unfamiliar, but as you go through it, it's easy for the kids. Because like, even with our fingers, right? We have 5 fingers. You grab 4, what's left? 1 is left. So it relates to everything that we have. If you grab 3, right? 2 is left. If you grab 2, 3 is left. If you grab 1, 4 is left. So the concept is there in our bodies. You just got to learn how to see it. That's all. When you understand it, it'll be easy to see. But we've been told in mainstream that you only need to memorize, but that's not what I'm trying to do. I'm trying to explain how to utilize concepts. Concepts are easy if you just take it as for what it is. Usually my students are fine with it. So we have 3 on the abacus. We have 1, 2, 3. We want to add the 3 again, but guess what? We don't have enough. That's where our nickel comes in. So if I give you my nickel, that's too much. I need to take away the 1. So my final answer is 7. 5, 6, 7. I could show you again on the abacus. I can add the 5 and then take away the 2. Right? Same thing. I add the 3. I have to take away the 2. I had a thought. It's got 5 beads. Just had the thought. It's got 5 beads like your hand has fingers. Exactly. You could say, this is a little dark. You could say this, if I had 3 on the abacus, I don't have enough. I need to have 3. I need to add 3. So I take my fingers, I give you 3 fingers, but I cannot chop my fingers off. So instead of taking these 2 fingers off, I would rather give you these 2 cubes. You could do that. Right? So then I keep my fingers and I just have this 1. So that would be 6. Your hands are 2-column abacus. Yes. Yep. You could do it with your fingers. There is a thing called finger abacus. I don't know how to do it specifically, but you can. So here we have 4, right? 4 on the abacus. 1, 2, 3, 4. I want to grab 3. I can do 3 fingers, but I want to keep these 2, but I got to give away 2. I got to take it away from here because it's loose. So 5, 6, 7. So my final answer is 7. I add the 5, take away the 2. So my final answer is 7. All right, cool. So how are we doing? So for those of you that just joined, thank you for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
And for those of you that have been here for a little bit, thank you for joining and welcome.
Welcome. to the real world.
I am here to show the matrix how to use the abacus. This is not just for enrichment program, and it's not just for accommodation. I think even the average Joe should know how to use the abacus because it makes math a lot easier. So I'm watching Total Recall now. That's funny. So yeah, and that's the thing, right? Like understanding how to use the concept, understanding how to use the abacus, I think is the greatest thing because we can now visualize our numbers. If I have 4 on the abacus, I want to add the 2, but I cannot add the 2. Here, in this specific question, I said, we go to the cats in the tree. There's 5 cats in the tree. So all we got to do is 5 cats in the tree. We grab 2 cats, but 3 cats run away. 1, 2, 3 run away. So I'm left with 6. That's what I do there, right? We could do it again with the 3 and the 2. So we have 3 on the abacus, 1, 2, 3. We got to add the 2, but there's not enough. I got to go to the cats in the tree. There's 5 cats in the tree, but because I grabbed 2, 3 cats run away. Thank you, Get Money J. Thank you so much for the share. So my final answer is 5. 5. Right? And what are we doing is we're just understanding concepts. So because after we understand this concept, then we know how to take away. Because if you know how to add, you will know how to subtract. 4 doesn't have a thank you, Get Money. Thank you so much, Jay. So we have 1 plus 1, right? We have 1 plus 1 is 2. And then we have enough. We have 2 plus 1 is 3. We still have enough. We have 3 plus 1 is 4. Now, thank you, Jay. Thank you, Jay. Now, if you look, if I want to add the 1, I have no more beads, but I have to use this formula. Plus the 5 minus the 4. Plus the 5 minus the 4. My clothes are in the dryer now, so I'm going to head to bed. Okay, see you later, Smooth Operator. Thank you so much for dropping by. I appreciate that. And I'll see you in my next live. Thank you, Jay, so much for the share. So what we're looking at is understanding the concept. And then the rest of the book, oh, I didn't do that. So the rest of the book is about solidifying the concepts. We have color by number, we have the mazes, and the mazes is still talking about this. And then we have the hidden word, we have word problems, and then we have mazes. Again, we have color by number, and after color by number we have more questions. We have tic-tac-toe, right? We have tic-tac-toe, answer the questions, place your marker, and then have your answer. And then we have more quizzes, we have more word problems, and that's it. And if you're ever interested, I do have answers in the back of the book, just in case. Yep. Uses this. I'm glad I found you. Interested in a long time. Oh, hey. I wonder, the Chinese restaurant, do they use the 2 and 5 or the 1 and 4? This is a Japanese abacus. I'm wondering if the Chinese restaurant uses this one or the other one. So apparently, like, it became more common to use this one. It's the more modern one, and it started to get more. I mean, that's where all the YouTubers that do abacus, they're all a Sorobon method. I haven't seen anybody that does Chinese method, because the Chinese method is about counting up, whereas other one, oh, I'm in Texas. Yeah. So then that means it's this one over here. So there's two beads on top, 5 beads on the bottom. So, yeah, it's still in circulation, but not too many people know how to use this one anymore. Excuse me. So when we count, we have 1, 2, 3, 4, 5. Because there's 5 here, we're going to trade it in. So that's 5. And then we do 6, 7, 8, 9, 10. Because there's 5 here, we're going to trade it in. And then we have to trade this in again to this. This is 10. 1 and a 0. Which is very similar to the abacus way. It's the Japanese way. Japanese is 1, 2, 3, 4. And then 5. We don't need to trade it in on the Japanese one. We have 6, 7, 8, 9. And then we have 10. Again, we don't need to trade it in. We just got to go to the next number. Yeah. I don't teach the one with two beads. Because that's a Chinese way, and that's not the modern one. Not too many people use the Chinese way. Only old Chinese people use the Chinese method. I like the 1 and 5. Yeah, yeah. The only thing with this one is that you have to know your formulas, and your formulas is this: how to make a 5 and how to make a 10. If once you know how to do these two, then you can actually scale it. Whereas in Abacus, in the Chinese Abacus, I heard that they have to count up. And that's like a whole lot of counting up, which is crazy. Do you have to go from right to left? No, I usually go from left to right. Yeah, the lady's really old. Yeah. Yeah, you know what's really interesting? Like I have a Chinese bank, and they still have the Chinese Abacus as part of the where you sign your deposit slips, and it's for the old Chinese people. But I don't think any of the new people, I don't think anybody young knows how to use it. Excuse me. All right, thank you for the follow. So does that make sense? I don't know what your name is, but we don't do right to left. I usually go from left to right because I feel like it's more natural that way. All right. So what are we doing? We are looking at how to make a 10. Hello everybody. Hello. Thank you everybody for joining. Let's see. I got to find it. Make it 10. There we go. Okay. Now again, what are we doing? We're understanding this concept, how to make a 10. We need to know that 5 plus 5 is equal to 10. 2 plus 8 is equal to 10. 7 plus 3, 4 plus 6, 1 plus 9. So when we're looking, we have 8 on the abacus. No, we don't. We have 9 on the abacus. So the question is what? 9 plus 2. 9 plus 8. 9 plus 8. 9 on the abacus. We want to add the 8. So if you notice, it's going to be plus the 10 minus the 2. That is our formula. Right? What we're looking at is the concept. Now, why are we going to do this? Well, we know that 8, to make a 10, you need to add the 2. But it has to come from somewhere. It has to come from the 9. Because it has to come from the 9, I take it away from the 9. I've made my 10, and I just add the 10. That's it. So my final answer is 17. Excuse me. So again, we don't memorize our digits. We don't memorize our doubles. What we're going to do is we're going to understand this concept. Let's see this. We have 8 on the abacus. We have 8 on the abacus. I want to add another 8, right? When I add another 8, what am I going to do? Well, I could bring it together, or I can organize it. I have 8 on the abacus. This is the 8 right here. I want to add an 8 here. And guess what? If I make a 10 out of this, I need to do 2. Where am I going to get the 2 from? I take it away from the previous 8. And I add it to my second number, which is 8. So it's 5, 6, 7, 8, 9, 10. This is 10. I've made my 10. Now all I got to do is just show it. So my final answer is, whoa, there we go, 16. Wow. Right? So we could do it again. If I have 7 on the abacus, nope. If I have 7 on the abacus, excuse me, I want to add 8. To add the 8, here is my 8. Notice, to make a 10 out of the 8, I just need to add 2. Where am I going to get the 2 from? I can get it from here. This is where I can get it from. I can get it from the 7. So I take it from the 7 and I put it to my 8. I just made a 10. So I add the 10 on the abacus and I take away the 2. Because that's what I did. I took away the 2. So my final answer is 15. That's it. Thank you everybody for joining. For those of you that just joined, my name is Lynette, and here is how we count. Let's do a little recap. We have 1, 2, 3, 4. Anytime the beads are touching the reckoning bar, this is counted. So we have 4 and then 5. 5 will always be the top bead. We have 6, 7, 8, 9, and then 10. That's it. All right. How are we doing? So what did we just do? We understand how to make a 10. Thank you. Thank you, me. I think I'm thinking about done. I'm actually getting kind of tired. Okay, how are we doing? But does that make sense to make a 10 at the bottom? The number, the second number is we want to make a 10. See, and that's the thing, like in mainstream math, it's kind of interesting because they do a flip-flop. They go both ways. But in Abacus, we don't. We go only one way. We go from the bottom up. So if I have 7 on the Abacus, 1, 2, 3, I'm sorry, 7, 5, 6, 7. We want to add the 4. We're not going to make the 10 out of the 7. Right? Because we don't have it on the Abacus. We're going to make the 10 out of the 4. To do that, we need to take away the 6. And then I made my 10. I got to show that. So my final answer is 11. Thank you, lemon. Thank you, me. I appreciate that. Right? So the difference is in mainstream math, they'll say, oh, this is 8, we can make a 10 out of it. But then guess what? Where do you get the 2 from? They take it from thin air. But in Abacus, we don't take it from thin air. We actually take it from here. So if I have 8 on the Abacus, I need to make a 10 here. This is where I make the 10, at the 4. To make the 10, what do? I need to get 6 from somewhere. If I get 6 from the 8, that's all I got to do. Take away the 6 and then add the 10. So it's just like drifting.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
You need to subtract before you add is what we were doing. And that's the reason why we had the concept. So if we had 6 on the Abacus, we have to add the 4. But to add the 4 here, right, we want to make a 10 at this bottom one. To do that, we have to minus the 6 from the 6 and then add the 10. So my final answer is 10. Thank you, Demon. Is that from Zoolander? No, that's Cars. That's from Cars.
If you're going hard enough left, you'll find yourself turning right.
Do you hear that?
Oh, right. That makes perfect sense. Turn right to go left.
This one, I like this one.
Oh, I love it. Great stuff.
That one's from Starsky and Hutch. Hello, Mr. Clean. Hello, Mr. Clean. How are you doing? Mini Ninja came by. I don't know who Mini Ninja is. It's so many people. It is. It is. It's quite exciting. I don't know whose older brother is Mini Ninja. So I'm trying to go through all the kids that I know. They say that the kid is smarter, that the brother is smarter. I just assume it was you. I'm doing awesome. I need a refresher on division. Oh boy. Do you have a question or do you want me to? Please don't swear. You don't need to swear in this room. Do you have a question, Mr. Clean, or do you want me to think of one? Okay. So, what is our starting point? I haven't been here for division yet. I just got him all the way. It's going to be easy on the dot. You're right. 472. This is our dividend. This is the dividend. This is the divisor. We need to figure out where our starting point is. Just like in multiplication, right? In multiplication, we need to know where our starting point is. Same thing with the division. division, we have our dividend, and we have our divisor. How many dividends and how many divisors we have, right? How many digits of the dividend do we have? We have 2 dividends. 2 dividends, right? Minus the 1 dividend. Thank you. Thank you, Mr. Clean. Right? So we have 2 take away 1 is equal to 1. So when we are looking at it, we're going to be here. What did we just do? We have, now what we're going to do is we're going to put 72 on the abacus. This is my dividend. Why are we going to put on the abacus? One is because to have it as a placeholder. And the second one is it's going to help us understand where to put our quotient. So what are we going to do? Thank you, Swiss. Right? What are we going to do? Well, we got to multiply it out. 4 times what is equal to 7 or less? Can we do it? We can. So we have to skip this. So we're over here. That's why. Because it's a single digit, we need to skip it. We can do it. 4 times 2 is too much. 4 times 1. 4 times 1 is equal to 4. 4 is a single digit. Oh, no, wait. Take away 4. How do we take away 4 from here? Minus the 4 is equal to minus the 5 plus the 1. Minus the 5 plus the 1. So we're left with 3. So when I look, we have 3. 4 times what is equal to 3? That does not work. We need to make this 3 a double digit. What do we do? How do I make this a double digit? What do I do? Yes, I have to bring down the 2. I have to bring down the 2. I don't need to bring down the 2 in mainstream math, right? Because on the abacus I see I have 2. I just need to look right here. Use this one. I don't need to bring it down. If we talk about long division, yes, you got to bring down the 2. But if you see it on the abacus, I see the 3 and I see the 2. You know what I mean? So I just need to remember what my question is. 4 times 32. What times 32 is equal to 8? I'm sorry, what time? It's just 8. 4 times 8 is equal to 32. Right? So that's what I'm saying. You use this to help you. Don't look at this. I use this to show you how we do long division. But we add the 8 on the abacus. We have 5, 6, 7, 8. We take away 30. We take away 2. Yeah. Yeah. So in mainstream, you have to bring it down because you're on paper. But on the abacus, you just see it. So remember, we said 4 times what is equal to 3? That doesn't work. It should be 4 times what is equal to 32. Add the 8, take away the 3. So what we do is if I never show you, then I'd do it on the abacus. That's what I would do. So I'd do it again. I'd be 72, and then I need to know 7 times 1 is equal to 4. I'm sorry, 4 times 1 is equal to 4. Add the 1, take away the 4. Take away 4 is minus the 5 plus the 1. So then I'm left with 32. Next time I'll ask for a double-digit division. I'll let you teach the other. You know, the double-digit division's a little bit more complicated. You just need to make sure that you understand it. Why do you start at the tens column? The reason why is because when I do the multiplication out, if I can multiply it out like this, the question is what times 4 is equal to 7? I need to go back 1 column. That's why. You aren't memorizing the 4 times 8. You have to memorize 4 times 8. You have to memorize your single digit multiplication. Yeah. So here, because I can do that, I have to skip. Because I would start from here in my quotient. And if I can do 7, then that means I got to skip this and go here. Do you have to memorize up to 9 times 9? Yes. Yes, you got to go all the way up to 9 times 9 on the abacus. Because after that, like 9 times 10 is redundant. Right? Why? Because we still do distributive property. What if it's 8. If it's 8, it's still, you got to skip it. Because it's 4 times what is equal to 8. You can do it. You got to skip it. The problem is if it's 4 times something like 3, then you got to find your second digit. Does that make sense? If it's 4 times 4, right? 4 times what is equal to 4? You got to move back one column because you can do it. But if I cannot do it, then I got to bring that down. Does that make sense to me? 1.8. Kinda. Right? Same thing. If I did 4 times 2, I have to go back one column. Can I show 8 times 4? And then, wait, but then we are memorizing, isn't it? Are we trying to do? What are we trying to do? Well, if I did 4 plus, I'm sorry, you can do repetitive addition, right? So if I did 8 times 1 is equal to 8. 8 times 2, add an 8, plus the 10 minus the 2. 8 times 3, can I add the 8? No. I have to plus the 10 minus the 2, minus the 2, minus the 5 plus the 3. 8 times 4 is equal to, how do I add the 8 here? Add the 8 is plus the 10 minus the 2. So my answer is 32. Lemon, did that make sense? Are you on earlier too? I wasn't on earlier. I was doing things. I was working on my 15th book. Yeah, I missed that. Sorry. You do additive multiplication. I get the multiplication. I probably just need to do a few repetitions of division. Yeah, yeah. Division is easy when it works itself out. Oh, thank you, Mr. Clean. Thank you, Mr. Clean. But we need to memorize. But we used memorization for division example. Well, you need to know you need to be fluent in your multiplication facts. If I add 9 and then I add the 10. Thank you, beef and cheese burrito. Last night the multiplication exercise was yeah. Yeah. And when I build out my division workbook, it will be exactly the same process as well. You'll start off easy and then it will start making its way to more difficult. So, I'm struggling to understand the abacus. Small fire. I'm so happy to see you grow more. Thank you so much, Mr. Clean. Thank you, everybody, for joining. So to read the abacus, thank you, small fire. This is 1. Anytime the beads is touching this reckoning bar, this is considered counted. This is 2. This is 3. This is 4. 1, 2, 3, 4. Here we go. 5. When I first joined, there was only 5 of us. Yeah, yeah. It was a really small group, right? And we did a lot. And then we started doing 2-digit divisions, and then I realized that was just too much, right? But yeah, I started reading it. I said, this is 5. We have 6. Notice if I have 1, I add the 5, we have 6. If I have 2, I add the 5, we have 7. 5, 6, 7. We have 3, 1, 2, 3. We add the 5, we have 8. If we have 4, 1, 2, 3, 4, add the 5, we have 9. 6 looks like that. I appreciate the stream, super valuable. Thank you, me. This is what 6 is. 6 looks like that. 7. Thank you for the follow. So when we're looking, we're understanding how to do things. So treasure. Yeah, you still need to understand your multiplication, right? The idea for the multiplication math fact is we don't need to do what mainstream does. Mainstream does, when we do the bigger numbers, they have to write everything out. But in Abacus, we don't need to write it out. Okay, Mr. Clean. Have a good night, Mr. Clean. Thank you so much for dropping by. So, if we did this activity, here you go. What number do you think this is? What number do you think that is? So my tens and I have my ones. What number do you think that is? $44. No. No. We said this is 1. Thank you, Lemon. This is 1. I don't know how you got 44. I don't know how you got 8. Because this is 4. 1, 2, 3, 4. How do you get 5? We don't add these together. Every column is a placeholder. Every column is a place value. We have our tens, our ones, our 10. We have our tens, our ones, our tens, our hundreds, our thousands, our 10,000s. No, this is not 5. We're not counting it together. I just mentioned that this is 5. I just said this is 5. Thank you. Yes, so it's 1, 10, 100, thousands, 10,000s. Yes. The top bead is a value of 5. That's how you get 5. Every number is a representation. This is 4. This is 40. 4 and a 0. This is 3. This is a 3. This is 30. This is 300. This is 3,000. So when I do this, 1 tens. There's 1 tens. 4 ones. Thank you, Madge. So when I look at it, 14, now I have my next number. What is my next number? I have my ones, and then I have my tens. Thank you, Jess. It's 2. Thank you, Lemon. It is not, I don't know how you got 36. So how does it work with the Abacus? Are they still 5? Yes, they are still 5. It is 2. Yes, beef and cheese burrito. It is 2. Sierra, I don't know how you got 36. I don't even know how you got 32. I cannot for the life of me figure out how you got 32. Yes, it's 2. 1, 2. This is not counted, right? This is my reckoning bar. It's not counted. If there was this, then it's counted. But this is a 0. Only the top, only when the beads are touching this reckoning bar is it counted. So we have this. This is 7 because the top bead is touching the reckoning bar. The 2 beads at the bottom is touching the reckoning bar. So when we're looking, this is where we get 2 digits. We have our tens, and then we have our ones. How are kids replicating this device in their minds, in their hands? They're not replicating it in their hands. They're replicating it in their mind's eye. 32. Yes. 5, 6, 7? No. 5, 6, 7. We have to remember the top bead. The top bead is a value of 5. You have to remember that the top bead touches the reckoning bar. So we have the top bead that touches the reckoning bar. This is 7. 5, 6, 7. 5, 6, 7, 8. It's like pennies and nickels if you did the sevens. Those. Yes, K. So here, I have 7. 5, 5, 6, 7. That's what 7 looks like. 8 looks like that. 5, 6, 7, 8. So yes, it is 78. Thank you, Madge. It is not 33. Thank you, Sierra. So it's 78. Oh, so on this abacus, it would be 78. Yep, it still looked the same. So our next number is... What's our next number? Oh, which one are we doing? We're doing... I don't know. We're doing this one. There we go. There we go. Okay. Great. 2 beads add to 10. Yes, so this is 2. 1, 2. So this would be 20. Yes, beef cheese burrito. It is 22. You're right. Sugar. Yes, thank you, Lipum. Have a good night, Sierra. Yes. Good, Jess. Even top beads. If I add the top beads, this would be 77. This is 55. 66, 77. 22. Chat is so... What number do we have? It's actually this one. That's all it is. $10. Exactly. It is 10. Easy, right? What's our next number? We have our 10s and our 1s. 10s and our 1s. 33. Thank you, Madge. Yes, 33. Thank you. Thank you. Thank you. What's our next number? We have our 10s and we have our 1s. What number do we think that is? $90. Thank you, Jess. 5, 6, 7, 8, 9. 6. 5, 6. Well done. Well done. 96. And then we're down to here. So for those of you that are interested, my whole collection is over here, but I am planning to stock my TikTok shop. I have my 10s and I have my 1s. I have my 10s. Thank you, Gio. 5, 6, 7, 8, and then 2. 1, 2. Well done. Thank you, Madge. That is what 82 looks like. So we have 8, 5, 6, 7, 8, and then 2. Our brains are so fried. Always react to 6, 7. Yeah. 6, 7 is not a... 6, 7 is not a comment that really... It's just a bunch of people coming into the live, and it's like talking out loud before sitting down and just observe a little bit. Just observe a little bit. I always catch this live and I'm still so lost. Okay, EB. So here we go, EB. Yes, exactly. Is the 5, the top bead is always 5. So when I have this is 1, this is 2, 3, 4. Remember, this is 1. If I add the 5, now we have 6. 5, 6. If I have 2, add the 5, we have 7. 5, 6, 7. 3, 1, 2, 3. Add the 5, now we have 8. 4, 1, 2, 3, 4. We add the 5, now we have 9. Does that make sense, EB? So then you might be wondering, well, what's after 9? 9 is 10. 10, 1, and a 0. Did I just read your mind? 1 and a 0. Now now this is 11, right? If I did this, this would be 21. And then this is 22. This is 32, 33, 43, 44. I understood it better once I knew place value units. Yeah. Kind of understanding. 44, 54. That's what 67 is. This is 66. 76, 77. 78, 88. 90, 89, 89, 99. 100. 1, 10, 100, 1,000, 10,000. Right? Same thing with the 5. 5, 50, 500, 5,000, 50,000. EB, does that make sense? Are the values, are each row never changes? It usually does not change. 200, 1, 2, 1, 3. 1, 2, 3. It just depends on where you locate. Which one do you want to be your ones place? You can be this to be your ones or this to be your ones. So if this is your ones, then everything moves over like that. Okay, so from left to right, no. Left to right is 10,000. 10, 0, 0, 0, 0. Not a problem, small fire. This 1,000, 1, 0, 0, 0. 100, 100, 1, 0, 0. 10, 1, 0. So it's still 10. Does that make sense, EB? We still count from left to right. We still count from left to right. Oh, thank you for the lightning bolt, small fire. I'm lost again. Hold on. Why are the last two on the right? Because it's the tenth. This is the decimals. This is the tenths, and this is the hundredths. This is 6, 0, comma, 1, 2, 3. Can't see that. There we go. Sorry, 1, 6. That's what 6 looks like. If I did this, 6, 6,000, 0, 0, 0. 600, 0, 0. Right? 0, 0. 60, 6, 0. Oh, good. How old is your daughter, Gio? How old is your daughter? What's next? 6. EB, does that make sense? 9. Oh, if she's 9, I would recommend doing a 3-digit maze or a 4-digit maze. And it is available in the other place. I don't have any right now in stock, but I only sell the Abacus. My whole book collection is over here, but I am trying to populate my. Excuse me. I'm trying to populate my TikTok shop. Oh my god, it makes sense now. I know that they're yes. So every one of them, right? 25. 6 6 25. Wait, I am adapting. Great. Great.
Oh, I can see everything.
Thank you, Small Fire, for the gifts. Bat pick. That's interesting. And the friends. Just mess. You're the best live out there right now. Thank you. Thank you. Even though I'm a little bit tired. Yeah, it was just one of those days that I didn't get a good night's sleep. So I'm like, I don't know what I'm doing, but I should show up. I need to show the Matrix what an abacus is. You're still up. It's only 12 for me right now. I know it's like 3 o'clock for those people in the East Coast. It's crazy. I'm about to sleep. Yes. Have a good night, Mr. Lee. Have a good night. Right? Yeah. It's crazy though. It's so crazy. Oh, you're in San Francisco? Oh, that's cool. Yeah, I'm in LA. It's 2 a.m. See, that's what I'm saying, Jess. Like, it's late. No, it gets really late. It's crazy. I have East Coast people, and we'll go to like 4 or 5 in the morning for them. And I'm like, oh my God, they're still learning math. So that's what it is. Decimals is just the next placement over. That's it. Is late. Ha! Yeah. This is refreshing my brain. This is such an amazing tool. Thank you, Jonathan. I'll be up at 7. Good night, Mr. Lee. I'm in Texas. It's 2 a.m. Yes. It's very late for, yes. And that's what it is. And so, Jonathan, just so you know, depending, like, it's helped to, it's like brain gymnastics for us old people to keep your mind active. And I do notice there are some people that are a little bit on the older side, and they started doing the abacus method in their adding and subtracting. And because they're doing adding subtracting method in abacus way, they have noticed that they're starting to think a little bit quicker than they usually, which is really kind of cool. So
this is the way.
This is the way.
This is the way.
okay, so does that make sense? Okay, so EB says that made sense. Yeah. When do you usually host your live? I want to actually learn more about. Usually I try to get on about 8 or 9 Pacific Standard Time. Today I was actually late. I try to go on 8 p.m. Pacific Standard Time, and then during the day, but that's not really set. I wish I could set it, but I don't, because it all depends on what time I go to bed. I'm trying to get in the morning, but I've been going to bed pretty late that I haven't been able to get the morning crew. But yeah, Pacific Standard Time, 8 p.m. roughly. Today was late. I was at 10. So, yeah. Beef and cheese burrito. Thank you. No, thank you. I appreciate that you followed. Would you eat? Yes. Can you show me? Yes. So we have, do you have a book? That's not a stupid question. Do you have a book to go along with the abacus to test ourselves? Yes. I pinned it down. I pinned it. If you're looking for 2 digits, I pinned it. It comes with a book like this. And what we're doing is we're doing the 10s and the 1s. And this is the maze. So that's what we did, is we did the maze. And you go through and you figure out what these numbers are, and then you find out what the path is. That's my whole book. And then this is the reverse maze. So I give you the path, and you need to figure out what the number is. She's soon. Waiting. Yeah. And then if you're ever curious or concerned or not sure what the answer is, I do have answers in the back of the book. Yeah. I give you a brief introduction on how to read the abacus, and then I go into how do you do double digits, tens and ones. So we do a review just in case we forgot how to put it into boxes, and then how it relates to the abacus. Yeah. I also give you a mask maze because, and I also give you the opportunity to download it because the paper is a little thin and you want to cover the answer. So this is a file folder, and so I cover the answer. Because it's easy to know, you can do a process of elimination here. So this is 95. You know what I mean? Right there. Yeah. Yeah, it's going to be a little bit for my stock to replenish. Yeah. Yeah, it's crazy. It's crazy because So, thank you guys. Oh, hey, 10,000K. Welcome everybody, welcome. Not a problem, Renee. Thank you for the question. Kieni? Dien? Kadeni. Denny? Thank you for the share. Let's do a little review on the abacus. So we have our 1, the top bead, no. The bottom bead touching this reckoning bar is considered counted. This is 1. We have 2, 3, 4, and then 5. This is the top bead of 5. And we have 6, 7, 8, 9, and then 10. After 10, 1 and a 0, we have 11, 12, 13, 14. Thank you, Joan of Arc, for the reminder. Thank you for the follow. And then we have 15, 15, 16, 17, 18, 19, and then 20. The adult version? Yeah, there is an adult version. It looks like this. Let me... That's the adult version. And it's available over there. If you're interested. It's a little bit faster. Oops. What are you doing? No, just photos. Ugh. So there we are. So that's the adult version. Don't worry, guys. I'll speed run the adult version. This hurts my brain. Okay. Wait. So the blue ones equals to 5. I took a screenshot. 5. Yep. So 5, 50, 500, 5,000, 50,000. So when we write it, right, we can go back to this. So 60,000, that's what it looks like. And then we have 6,000, 6000, 600, looks like that, 600, 60, looks like that, 6 and a 0. And then that's what 6 looks like. Yep. Thank you so much for checking in, aces. Yeah. And so what are we doing is every column is a place value. We have our ones, tens, hundred, thousands, 10,000s. What about the other two? Those are decimals. Tenths and then the hundredths. Where were you when I was in high school? Can you show an example of a decimal? Yeah, easy. $2.25. $2.25. That's it. to 6, add the 1, add the 8. Plus the 8 is equal to plus the 10 minus 2. Plus the 10, take away the 2. Cannot take away 2. Minus 2 is equal to minus 5 plus 3. Minus the 5 plus the 3. So my final answer is 4.40. Denny, I thought your brain hurt. If I showed you multiplication, I think your brain's going to explode. If your brain hurt from counting, I don't think going to multiplication is going to make it better. Yeah. So ACEs, when we're looking at it, this is our two-step equations. I guess you can say it's a brain blast. Oh yeah, so this is our two-step equation. That's what we have to pay attention to. Do you know why? Because 6, right? We have 6, or no, 6. 6. We want to add the 2. Take away the 2. Cannot take away the 2, right? We only have 1 there. So we actually have to minus the 5 plus the 1. So I have to minus the 5, plus the 3 and add the 3. That's why this is a two-step equation. Because this 2 works exactly the same. You just got to bring this information and substitute it there. Yeah, so that's a good question. But yeah, that's how you do 440. 440. That's it. Whoa. Wow. I can't believe there's still 130 people here. Okay. So, I am thinking about ending the live. Just one last time. We're going to do 1, 2, 3, 4, and then 5. 6, 7, 8, 9. Okay, Aces. I will see you in my next live. I think I'm going to head to bed too. It's late. I got 4 more minutes and then I'll be here for like 2 hours. All right. Thank you, Flight. So when we have 9, right? 9, 9. See you tomorrow, Renee. See you tomorrow. We have 9. This is 9. This is 99. And then this is 999. That's it. And then we have 1,000. So 1,999. That's it. And what do you do on the abacus? You just add, subtract, multiply, and divide. But the first thing we need to do is understand how to read the abacus. That's it. So when we're looking, I enjoyed learning from you. I can pick up wherever you are, and it's fun. Oh, good, Britt. Right? And then if you have any questions, I can always go back and reaffirm. Because the thing is the understanding that there's formulas involved. So I'm very happy, Britt. Yes. Because, you have a foundation now, right? And it's easy to be able to like, oh, I know what that is. I've never seen this. This is what you call an abacus. An abacus is a counting tool. Oh, thank you, Britt. Thank you. Thank you for the comment. This is a counting tool. This counting tool is just telling me what my numbers are. So we have 1, 2, 3, 4. That's it. And we have 5. The top beat is a value of 5. Ooh, hello, hello, hello. And then we have 6, 5, 6. 5 plus 1 is 6. Notice that these beads are not touching the reckoning bar, so these are not counted. But if I did 2 like this is not counted, and these 2 beads are not counted. But then we add the 5, then now we have 7. 5, 6, 7. 5 plus 2 is 7. And then if I did 3, 1, 2, 3, the top bead is not counted because it's not touching the reckoning bar. But if I added it, it would be now 8. So we have 3 and then 8. 8 is 5 plus 3. And now we can decompose. 5 plus 3 is equal to 8. And then this is 4. 1, 2, 3, 4. We add the 5. Now we have 9. 5 plus 3. 5 plus 4. Excuse me. 5 plus 4 is equal to 9. You might be wondering what 10 is. 10 is a 1 and a 0 because every column is a place value. We have our 1s and our 10s. So this is 10 and the 0. That's it. We have 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. That's it. Because once you understand how to read the abacus, then we can go into doing adding and subtracting. So here is the next question, right? So we have 60,000, 60, 0, 0, 0, 0. 6,000 looks like this. 600 looks like this. 60 looks like that. Sorry. The highest number is at the 10,000. So it would be 99,999.99. That's what that would be. So it would look like this. 99,999.99. That's what that is. Oh, thank you so much, Louise. Thank you so much for the heart, finger heart. Yep, finger heart and the roses. Thank you so much. I appreciate the gifts. Yeah. Denny, does this make sense? So, okay. I've been doing a lot of yawning. I am going to head out. Thank you everybody for joining. I am going to head out. It's been ridiculous. All I'm doing is yawning. So, for those of you that just joined, thank you again. Oh, thank you so much for the gifts. Thank you so much, Louise, for the gifts. Any last minute questions about the abacus before I head out? I am gonna end it. I can't keep up right now. So, before I head out, are there any last minute questions other than trying to do multiplication? I am going to head out. Thank you so much for joining. Thank you so much for joining. And I'll see you all in my next live. Thank you. Thank you, Louise. Thank you so much. I appreciate that. Have a good night, everybody. Have a good night, Gio. Thank you, Mon. Thank you, Mon, for the share. All right. Have a good night, everybody. Toodaloo, kangaroos.